For chapter 6, the parts after acid and base. The parts after acid and base, that means we'll be mainly doing salt today. Salt, why we choose to do salt? Because salt is one of the most important chapter in your Form 4 and Form 5. This chapter, they give you a lot of information that you need in other chapter as well, which is like the observation, how to tell observation, okay, and then how to do equation, things like that. So in this chapter, to score in this chapter, you need to know these 5 things. It's like 5 skills or 5 knowledge, 5 info you have to know. That's first one is our solubility of salt. That means whether a chemical is soluble or insoluble. And then from the solubility, you will be able to tell, you will be able to tell whether the substance is a solution or solid. Okay, when they ask you questions, when they ask you to write equation or what, sometimes you don't really know whether it is solution or solid. Sometimes you see equation, they got write AQ. You ask me, hey, why there's AQ? How I know it is AQ? It's all from this chapter. Number 2, this is also the sequence that we will be doing today. We will be, after doing the solubility, we will do color of salt. We will do the color. Color, it is like when I ask you questions in the class, I asked what is the color of copper 2 sulfate solution, and then some will say, oh, it is a blue color, but some say I don't know, or even some will ask me, hey, how you know it's blue color? How they know it is blue color? This is where they learn from this chapter. Number 3 is heating of salt. Heating of salt is like a reaction. Okay, after you learn about salt, they heat it and it is a reaction. You have to know, oh, what are the product that is going to form. So these are the things they can ask you. So after heating, we do preparation of salt. That means you make salt. You make the salt. Lastly, ion test. Ion test. To be honest, it is actually impossible to finish this part in 2 hours. Even last time when we do 3-hour seminar, also we can't finish the whole thing. The most we can go through for today is until 4 only. Okay, I will make sure you know how to do these first 4 things. And it is not say more than enough, it's a lot already. The first 4 parts is a lot already. Okay, now we start with the page number 2. First thing, solubility of salt. So how people memorize whether a chemical substance is soluble or insoluble. Okay, this is the way. You can see this is the first group. This is our first group, second group, second group, third group. In the first group, they are all soluble salt. Okay, which you can see here, all soluble. I write it on the top, okay, so you can see. They are all soluble, meaning when the formula, the chemical substance has this sodium, potassium, ammonium, and nitrate. Sodium, potassium, ammonium, and nitrate. When you see these 4, which we call them as spent salt. Spent. Or what we call as spun also can. Spent salt. Sodium. If you see sodium, potassium, ammonium, and nitrate, straight away soluble. You don't have to care whether it is sodium chloride, sodium carbonate, sodium, your head is also soluble. As long as there is sodium, soluble. Easy. Okay, spent now. So first one, remember, this is how they memorize. Spent. Number 2. The second group is all insoluble. Or insoluble. All insoluble. The salts that contain COOH COOH. COOH is consists of CO, you see CO, OH, OH, and also O. So three things. Just now was span, now it's COOH. They are insoluble. So what does it mean insoluble? I give you one example. Let's say I will be giving you a lot of examples. I want to make sure you can understand this whole thing. So let's say no, we do this. K2CO3 soluble or not? Yes or no? Is K2CO3 soluble? Yes or no? Yes or no? By answering my question, I will know you understand or not. It doesn't matter if your answer is wrong. I know you or I do know you, you can always give me your answer. You are my student or not, my student also can give me answer. And please give me answer. So the answer is yes, soluble. Soluble. Huh? Why? I thought that is CO3. Okay, you see, this is the rule. This is the rule. How we do it is we always go through group by group. That means we will prioritize our group 1 first. That means if we can find span, sodium, potassium, we will straight away put a tick. We don't care what is at the back. Okay, group by group, like that. So when you see K, straight away soluble. Now another example. Let's say you check, so you always check the front. Is it span, sodium, potassium, ammonium? No. Is this nitrate? No. Not the group 1. If it is not the group 1, you check the group 2. COOH, CO, insoluble. Easy. Yeah. Now I give you one example. I give you one example. Okay. Soluble or not? Good. Yes, it is insoluble. Because you can't find span, sodium, potassium, ammonium, and nitrate. Cannot. And then COO, insoluble. Okay, last. Last. The last one. Oh, Shen Yi, you're here. Okay, last one, we go for this. NH4OH. Soluble or not? Wow, GG teacher, I got Malay edition. You didn't check the notes, man. When you got it, you got check or not? Hi, okay, yes, very good, very good. Yes, very good. Thanks for your answer. The answer is soluble. The answer is soluble because sodium, potassium, ammonium. Soluble. Even there is OH, we don't care. Okay, easy. Okay, now last part. Okay, you have already know how to do the most confusing part. If you know how to do the part already, you can actually ignore this part. You can actually ignore this one. Except means like what we did just now, we prioritize the first group. Okay, you can ignore this one. Now, last group. Last group is called the mostly soluble group. Mostly soluble. Okay, what is mostly soluble? Mostly soluble is like 90% of the times they are soluble. That means they are 10% not soluble, right? Not really 10. It's just I simply write the number one. Okay, you see, except when you see the word except means the 10%. The 10% is insoluble. When you see chloride and sulfate, most of the time they are soluble, except some examples are insoluble. So you are a smart student. Of course, you don't go memorize the 90%. We will memorize the 10%. You just have to memorize this 6 examples. As long as you can remember this 6 examples, are insoluble, then the rest all soluble. How to do? Okay, let me teach you a shortcut. Cl, C, we call it as rocky cyanide. C cyanide. Okay, C cyanide. S, we call it as a Soluble. Basically, roti canai is the food, right? Okay, Soluble is the Chinese food. Is one type of Chinese food. If you want to know how it looks like, you can Google search. It is just a pao. Okay, it's a pao that looks brown in color. They put it into it's not halal one. Okay, it's not halal one. They put it into the oven and then they make it until brown color. Okay, just like that. So we use this is to tell you that roti canai, CL, the C, when the roti canai is pairing with PB, AG, HG, they are insoluble. Hey, how come I relate roti canai to PB, AG, HG? Because we call PB, AG, HG as persatuan agama Hindu. By the way, this is not racist. No, no perkauman like this. No, it's just like traditional food. Okay, persatuan agama Hindu. Okay, like that. Roti canai. When they pair with the roti canai, is insoluble. Okay, by using this, it will be easier for you to remember. When they give you CL, okay, roti canai, if it is paired with persatuan agama AG, then insoluble. Persatuan, insoluble. Yeah, and then if we pair it with NA, you can check. Persatuan agama Hindu. Oh, not related. If it is not related, soluble. Okay, like that. Okay, last one. Siu bao, a Chinese food. By the way, Chinese food is a Chinese food, non-halal, non-halal. Okay, siu bao is persatuan. Persatuan bahasa Cina. Persatuan bahasa Cina. PBBACA. Okay, when you got the siu bao, you have to see whether it pair with the Persatuan Bahasa Cina or not. And by the way, China is CA, not the CU. Understand? Okay, so these are the three groups. Stan, COOH, roti canai, and siu bao. All right, let us try a few examples. Try. I give you an example. You tell me soluble or insoluble. Of course, you can refer back to the notes if you want. Okay, so let's say, okay, first one, Ag2SO4. Soluble or not? You can type Y or N. Y or N. Soluble or not? Okay, I see different answer. Okay, good. This is, okay, you can ask yourself, is this SPAN, sodium, potassium, ammonium nitrate? No. Do they contain COOH? No. Okay, this one must be siu bao. Siu bao, Persatuan Bahasa Cina. Persatuan Bahasa Cina. Not related. Then soluble. Okay, soluble, just like that. Now next, we got what? Okay, CuSO4. Soluble or not? Another siu bao again. Okay, yes, good. Siu bao. Persatuan Bahasa China. No, what? Is this not China? This is CU, so soluble. Okay, then what if the in this. Okay, ZnCl2, soluble or not? The answer is yes. Because what? Roti canai mah. Roti canai persatuan agama Hindu. Not related. Not related then soluble. Okay, last example, really last. The last example, okay. The last example, okay, last example, we do this. PbSO4. I know, Malcolm, you're so weak. I can throw a bit, Malcolm. I always give me wrong answer. So weak. Now, Malcolm, faster. Malcolm, okay, what is the answer? Yes, correct. Very good, Malcolm. Yes, the answer is insoluble. Good. Insoluble, insoluble, in. Siu Bao is pairing with persatuan. Siu Bao persatuan cannot insoluble. Okay, that's all. So this is all the solubility. So please make sure you are very good with all this span, COOH, and also roti canai and the siu bao. Okay, now next thing we do. So after solubility, we are going to do color. Color. Okay. Color is in page. Color is in page number 6. Color is in page number 6. So we look at page number 6. Color of salt. Okay, how people know about the color of salt? They actually memorize themselves, you know. So color, we have this general color. So please remember we have 3 general color. The blue color, the green, and the brown. When you see blue color, the first ion that comes to your mind, it has to be Cu2+. Every time Cu2+, all the Cu, when you see a blue solution, must be Cu2+. If you see a blue solid, it's also Cu2+. So that means whenever it's blue, it is Cu2+. Okay, we ignore the special example first. We ignore them first. You help me to remember the general one first. Next, Fe2+ is green, and Fe3+ is brown. Fe2+ is green. All the Fe2+ is green now. That means when you see green solution, Fe2+. When you see brown solution, Fe3+. Then, give you one example. FeCl3. What is the color of FeCl3? This is green, or it is a blue. It is the brown. The answer is brown. How to know? You have to know the charge, the actual charge. You put it back, okay? Fe3+, Cl-, so 3+ brown. Okay? Then how about this one? Color. Color. Ui. Color. Faster. Color. Green or brown. For those who give the wrong answer, I know you must be never memorize the formula or never memorize the charge properly. Okay, this one, the answer is green. Green. Why green? It's not every time you just put it back like that, Fe3 plus, because this is Fe2 plus CO3 2 minus the 3 is memang belongs to the CO1. It's not the number that Fe give to the CO. Just now it's different. Just now it's Fe2 plus Cl minus. Cl got no number. The 2 come from Fe. Okay, so green. Last one. Last one. Let's say CuSO4. I cannot remember already. I think almost the same. So okay, thanks. The answer is blue. That's all. Okay. So please remember these 3 common color, and then now you have to we have to go through the special example. CuCO3, remember CuCO3. All these special example they like to ask you in exam 1. They like to ask you in exam 1 because they are special. Students after they study Cu2 plus is blue, when they see CuCO3, or some of them will say blue, but actually this is green. Because this is green. Okay, green color. CuCO3 is green. And then CuO is black color. There is only one black color in this chapter. Every time you see black, CuO. CuO black, just like that. This one also always come out in the exam 1. These 2 are very important. So anything, okay, the rest of the example is like white color. The rest are white color. So what is the meaning of the rest? We know that CuCO3 is what color? Yes, green. CuCO3 is green color. Hey, but then let me ask you, I test you back on the solubility. Soluble or not? Soluble or not? Yes. Yes, very good. So if it is insoluble, we will call this as a green solid. So this is how people know whether it is a solid or a solution. Okay, then how about this? K2CO3. Hello? Hello. So you think, got Fe or not? Got Cu or not? No, right? What lah? What color? The salt is white. Soluble or not lah? Soluble or not? Oh yes, soluble. Then that means when I add water, I put water into this thing, I will get a solution, right? Okay, if it is soluble, then it can form solution. White solution, no? Agree, right? White salt and then white solution, no? Just now, if blue salt, blue solution, white salt, white solution, no? Correct? Correct? Right? Right? Correct, right? Correct. Wrong. The answer is colorless. Ayah. See, kena already lah. Okay, see, the salt that you buy from the market is white. Yes, I know the salt is white, but you put it into water, no color. After it dissolves, no color, so it's colorless solution. Remember, whoever write white solution, I laugh at you. Okay, cloudy white, where got? You see the seawater got cloudy white, where got? It's colorless solution. Remember, please. Okay, last already. I do one. Okay, finish okay. You look at green sea water. That one is not water green color. That one is the reflection. Yes, only solid is white, just like the salt that you eat. Sea is not blue color one. That one is the reflection. Reflection or refraction, I can't remember already. I think I learned in the physics. Okay, now you are left with this very example block, very important PBO ZNO. They always like to ask this in the exam. Why? Because they got two color. Brown when hot, yellow when cold. And then the zinc oxide is yellow when hot, white when cold. When you write your answer, you're going to write both. Okay. You can just ignore whatever is on the right hand side here. I give you one example because if the example is very bad, so we don't want to use it anymore. Okay, example peanut. Okay, why we call this as peanut? Peanut is basically it starts with P, right? The PBO starts with P, so it's peanut. I know many of you are going to disagree with this, but you don't have to argue with me. As I said, we don't want to use this anymore. Okay, I know it's bad example, but let me finish this story. So peanut, right? Let's say I buy a packet of peanut, with the one like that one. Okay, a very good one. Okay, we bought it. We open up the packet. You see inside, what is the color? The shell of the peanut is yellow, right? Okay, you don't have to give me any answer. No need. Okay. I think this is me. Me personally, I think it's yellow okay, light yellow color. The peanut. Okay, the peanut. Okay, like I don't know how to draw okay. How to draw? Okay, the peanut. Okay, whatever. Okay, it's yellow in color. And then when you go pasar malam, right, you see people who selling the steamed peanut. They steam it, right? And then when they steam it, the shell, the color will become darker, right? It becomes a dark brown color. So this is why I call it as peanut. Yellow when cold. When it is normal temperature, you open up and it is a normal cold, normal temperature, yellow color. But after you steam it hot, wow, brown. That's me, okay? That's me. But some students are going to argue and say, "Where God, it is brown, and then it's just become darker or something like that, or become yellow." Okay, never mind. So after that, after students start arguing with me on this peanut thing, I decided I don't want to use this anymore. We use another one. You can use this if you want. The oxide that always come out, the oxide that has color is the CuO, PbO, and ZnO only. So for these three special examples, first I arrange them in the sequence of this seminar covers salt only. Yes, of course. Even the salt also cannot finish already. Okay, we arrange it in the sequence of A to Z. Okay, alphabet according to the vertical arrangement. Okay, A to Z. So C comes first, P, and then the Z. CuO, what is the color? CuO, the darkest color, black color. From what I remember, teacher, what color is the salt if it is room temperature? Room temperature is cold. Cold is room temperature. CuO is black color. And then, as what I remember, color pencil, the color beside the black color is brown. Let's not talk about the gray okay, the brown, like they change color like from black, not like black become lighter, it's like black to another color is brown. Okay, brown. And brown to another color is like orange, right? But then this one is yellow. Zinc oxide is yellow when hot and then white when cold. So the color goes from darkest, like black, to white. And then the middle is brown and yellow. So if you can remember this, you can get the answer easily also. Black, brown, yellow, white. Okay, just like that. Later I will test you all this. And before that, before we do the next part, please remember that PbI2 is yellow in color. PbI2 is yellow. Finish. Now we try. Okay, I give you one example to try. I have a cup of water. And I'm doing an experiment. I put a few salts. White zebra and banana. No, we don't. Let's not talk about that. Okay, let's not talk about that. That one is really shit. Okay. No. Okay. We put the salt into the water. Okay, X. Okay, X. Let's say the salt X is Na2CO3. Will this salt dissolve into the water? Oh, good. Quite smart, huh? Yes, got sodium. Yes, it dissolved. And then what can you observe? What can you observe after it dissolved? Color. Yes, color. You see, I get white again. It's colorless. Not white. Not white. I know. Okay, see, the salt. Okay, the salt is white. But after you put it into water, it's colorless solution. It's colorless also, ma. Wow, you sure? When you buy the salt, it's colorless, man. You sure? You sure? You buy one and show me tomorrow. Okay, colorless solution. Then next, okay, if I put BaSO4. Wait, screen lagging. Okay, I put the BaSO4 into the water. What is the observation that you are going to see here? Yes, okay, very good. You all know that it's insoluble. And then the color is white, right? So you will see white solid, or you can call it as white precipitate. Precipitate means the solid that cannot dissolve. Solid that can't dissolve is like you have things in your water solution. It's called white precipitate. Okay, so both are acceptable, just like that. So by the way, give me 1 minute. I want to go toilet.
Hi. Hello.
Okay. Yeah, we continue. Okay, last example. Last example is I put PbI2 into water. So, for some people pointing already, so bad. Like you lah, Malcolm, that day you think I don't know. Okay, so this one. Okay lah. Okay, so hello, PbI2 into water, what do you see? They go toilet also. What temperature? Normal temperature. Normal temperature. Yes, good. PbI2 is insoluble. And then when you put it into the water, it don't dissolve, so you get a yellow solid or a yellow precipitate. Just like that. Okay, but then PbI2 and PbCl2, they are a bit, they can actually dissolve in hot water. The meaning of dissolve in hot water is hot money is normal water. If we heat it, we heat the water. What I'm doing? We heat the water, they will dissolve. Okay, I see. Okay, this is PbI2 dissolve. Dissolve. And then when you stop heating it, and when the temperature goes down, the solid will reappear again, the PbI2. Like that. Okay, so this is the meaning of dissolve in hot water, but insoluble in cold water. So one more part, and then we can start doing exercise already. And this is heating. The reaction, okay, heating is also known as decomposition reaction. That means when you heat a salt, they decompose. They decompose, they separate. So there are two types of salt that we will heat, or in exam, the two very common, popular types of salt that we heat is carbonate and nitrate. Yeah. When we heat the salt, what are the products produced? When you heat a salt, it always produces a residue and gas. Residue, what's residue? Residue is, let's say, barbecue. Let's say we barbecue, okay, party, and then after a few hours, we are all full already, and then we stop. What happens? All the charcoal, they will turn into the ash, right? Okay, so that's called residue. The things that remains there after you heating it. Okay, that's called residue and a type of gas. So when we look at this example, carbonate is CO3 2 minus. So when you heat something with CO3 2 minus, like zinc carbonate, you see, they produce a residue, zinc oxide, a gas, carbon dioxide. So this is the residue, this is the gas. And you will realize that, how come all the residue like the same one, like oh, yes, you are right. Residue is also mean metal oxide. So always, when you heat a salt, you always get a metal oxide and a gas. If you heat zinc is the metal, then zinc oxide. And then the gas comes from the CO3. You imagine CO3 is the mother, it's like the mom. When this mom gives birth to a child, the child should look like the mother, right? Okay, so CO3 will produce CO2. Almost similar, okay, CO3, CO2. And then the rest, you see, Pb, PbO, Mg, MgO, Ca, CaO, Cu, CuO, CO3 or CO2. Finish. Yes, ZnCO3 is insoluble, correct? And then now, right-hand side, nitrate, almost the same as carbonate, but nitrate is NO3 minus. So when we heat the salt, we still get metal oxide. Metal oxide is the residue. And then we get gas. Just now, CO3, we get CO2. Then now, NO3, we get NO2. CO3, CO2, NO3, NO2. But you can see this substance ZnNO3 is like a bigger compound compared to the ZnCO3. It still have a bracket. That means there are other things inside. So this is why it produces one additional gas O2. O2, that's all. So everything is the same. All metal oxide is either CO2 or NO2. But these come with one extra O2 gas. So that means what you have to remember is when a salt decomposes, the nitrate produces two gases. Carbonate only one gas. So when question give you one gas and two gas, you can straight away tell that, oh, when I see one gas, must be carbonate. When I see two gases, must be the nitrate. And help me to highlight one thing, then we can go through the exercise already. The one thing is nitrogen dioxide NO2 is a brown gas. Finish. Finish, huh? Now, we all go to page. We start from easier exercise first. We start from 28. 28 is the easiest one. 28 is the easiest question. Okay, let's see, 28. So here is the flow chart. We have salt P. The question says that P is insoluble. Wait, I'm lagging. My screen is lagging. Salt P is insoluble. Salt Q is soluble. They want you to name a process that is used to separate P and Q. One is soluble. Okay, this is insoluble and this is soluble. How to separate a salt that is insoluble and a salt that is soluble? Let's say you accidentally mix a packet of salt with sand. How do you separate them? What is the process that you use? Yes, very good. This is like what you learned in the Form 4 last time. Filtration. That means you add water. Why so lag? Filtration. You add water, you dissolve it, and then you filter it. So the one that is insoluble will be on the top. Like that. So now, when salt P is being heated, it produces a residue W and gas X. Another one, residue V, gas Y, gas Z. One gas, two gases. So obviously, wait, let me share the screen again. I don't know why it's lagging. Wait, how come I can't share the screen anymore? GG lah, oi. I'm trying my best to reconnect back. You all try the question first. Wait, you all try the question first. Okay, not all. Why so bad? Okay, back. Oh, finally. Okay, so we see. Yeah. Okay. So one gas and two gases. One gas, we know that must be carbonate. And when we see two gases, it must be the nitrate. Okay, now, question B. Gas X can turn lime water chalky. Hi, yeah, this one's so easy. Lime water chalky must be carbon dioxide. They say gas X is carbon dioxide. Without reading the question, I can already tell that the gas X is carbon dioxide because one gas must be carbon dioxide. Hence, the N ion is carbonate. N ion, they're asking like, hey, who is the mama? Okay, when the kid is CO2, so it has to be something that looks like the kid. Okay, CO3, 2 minus, just like that. Okay, and then continue. Residue W is yellow when hot, white when cold. Yellow when hot, white when cold. According to what I said, Cu, Pb, Zn. The first one is black, and then the last one is white. Must be this one lah. Zinc oxide lah. Zinc oxide. What happened to the pen? Okay, and then if it is CNO and CO2, then the salt must be zinc carbonate. It must be zinc carbonate lah. Zinc and carbonate together, zinc carbonate. And then next, gas X is a brown gas. Gas Z, not X, this is gas Y. Gas Y is brown gas. Gas Z rekindle a glowing wooden splinter. If right formula cannot. They said gas Y is brown. Brown must be NO2 lah. And then rekindle a glowing wooden splinter must be O2 lah. Even without reading the question, I already know. When I see two gas, I know higher, definitely NO2 and O2. Smart army. Okay, next. So this is nitrogen dioxide gas. CO2 is carbon dioxide, right? So NO2 will be nitrogen dioxide. This one, oxygen gas. So what is the N ion present in the salt? So if the salt has NO2, O2 higher, NO3 negative lah, nitrate ion. This is how. Okay, and then residue V is brown when hot, yellow when cold. Okay, Brown when hot, yellow when cold, black is here, white is here. Then this one must be PbO lah. What is the name of PbO? What do we call PbO? We are writing the name. What is PbO? PbO. You see, many of you is going to get wrong answer. PbO, hi, yeah. Last time no study hard lah, now hi. It is lead 2 oxide. Never write lead oxide only. It has to be lead 2. When do you have to add a 2? You have to always add a 2 whenever it is Pb, Cu, and Fe. Because they have many different oxy, I got remember good. Okay, good thing. Okay, because they have more than one charge, more than one charges. How to know if it is 2 or not? PbO, you see, PbO. When you ask this question, I know you never memorize the charge one. PbO, how you get PbO? Pb2 plus and O2 minus, then must be 2. Memorize the charge, please memorize the charge. For those who got zero knowledge for Form 4, memorize the charge. All the Form 4 kids, they can memorize the charge now. If you cannot memorize the charge, the kids will laugh at you. The Form 4 one. Okay, so lead 2 oxide. Based on E and F, the salt will be lead 2 nitrate. That's all. Okay, so easy one. This is a warm-up question. Now, we will be going to, wait, let me find which page you can do. Okay, we look at the next page. Next page. We only do the middle part here. This is the only part you can do now. So when we hit zinc carbonate, I get substance R and gas S. What is the substance R? What is substance R? When I hit zinc carbonate. Aiyo, why like that? Yes, when you hit a salt, you always get metal oxide and gas. So this one is zinc oxide. And also what gas? Carbonate, carbon dioxide. So here, our answer for B, state the observation. So what is the observation? Observation is asking you, what can you see when the product is formed? Can you see? What you can see means the color, What is the color? Wait, my iPad no more battery away. How? The cable so short. Aiya. ZNO. Okay, see, you see, ZNO. You do like that. CU, PB, ZN. Darkest color, black. And then this is white. Got 2 color, right? White and something. White and yellow. Yes. So you must write a residue, or you can write a solid also. Okay, a residue or a solid, which is yellow when hot, white when cold. It's formed, it's produced. Okay, So a chemical test for gas S. Gas S is carbon dioxide gas. How do we test carbon dioxide gas? Yes, the lime water. Yes, the lime water turns cloudy. We just write a short one, okay? Save our time. We just write a short one. Lime water, cloudy, like that. Then we are going to this one. Okay, we do this one. Okay, next page. When we hit copper 2 carbonate, okay, let me test you. Copper 2 carbonate soluble or not? Soluble or not? Yes, good. It's not soluble. Color? Green, correct. Okay, carbonate. Green and then insoluble. Okay, when I hit this green solid, they ask you two observation. So when you hit CuCO3, the product produced will be metal oxide and gas, right? So CuO, the metal oxide, and also the gas, CO2. Yes, Erin, very good. So what can you observe when these products are produced? Yes, Erin. Okay. Yes, very good. When they ask you observation, you must tell me the color. So what is the color for CuO? Oh, yes, good. CuO is a black. Okay, so black residue is formed. So this reaction form a black residue and also CO2. What is the color of CO2? It's colorless gas, right? Okay, so we are going to write colorless gas release turn lime water cloudy. We don't just say colorless gas is released because we can't see the colorless gas. We will deliver the gas or flow the gas into lime water, and then we will see it turns cloudy. So colorless gas release turns lime water cloudy. So this is just CO2. We write it down, CO2. Okay, then no more. Okay, we can try donkey. We can try donkey. You see, observation. Oh, yes, sure, no problem. Can. You remind me again later. So after copper 2 carbonate, after the copper 2 carbonate completely decomposes, the residue form is added into a beaker containing sulfuric acid. So please write a chemical equation. Please write a chemical equation here. Write it into your book. Write it into your book. I give you 1 minute. I go check my iPad. I put this plug on. Not reach. I still cannot reach a higher. So short. Like Malcolm. Yeah. Wait, wait. Okay. Wow, when I charge iPad, some of them pointing again high, so big. So you see, this one, so bad lah. They all high. We see. So what is the cannot give people 2 minutes to charge iPad one man high. Okay, what is the observation when the residue is added into the sulfuric acid? And then write a chemical equation. Chemical equation. Residue is the CuO, copper 2 carbonate, right? Residue is CuO. So CuO plus the H2SO4 sulfuric acid, what we get? If you can remember the charge, then you can do this. What you do is just Cu2 plus O2 minus, and then H plus SO4 2 minus. Exchange the partner, you see? Cu, I pair with your girlfriend, like that. And you pair with another girl, like that. Exchange the partner. So you get CuSO4 plus H2O. So they ask you, observation. What can you see? When you put this CuO into H2SO4, what can you see? What can you see? CuO. Oh, your pencil, no battery, some more high. What can you see? When I say observe, you have to tell me color. So what color? Yes, you see the product. You see the product. CuSO4. What is the color of CuSO4? Yes. Soluble or not? Okay, I know. Okay. This is blue, right? Okay, Cu is blue. Soluble or not? Soluble. That means it can, when it mixes with water, it is a solution, right? It's a blue solution. So what happened is the black residue dissolved into H2SO4 to produce a blue solution. Like that. So after this chapter, you will know how people make all the observation, telling the color, this and that. Okay, so after this, another question. Okay, after this, we go to 33, page 33. Okay, you can only do, I think you can only do this part. Oh, there's another part you can do. Okay, zinc nitrate. Whenever zinc nitrate is heated, it produces a zinc oxide. Brown gas, colorless gas. What is the brown gas? What is the brown gas? In this chapter, only got one brown gas. When you see brown gas, automatically Nitrogen dioxide, good one. Colorless is O2, nitrate, nitrate. NO3 becomes NO2. So when I see brown gas, nitrogen dioxide, this one, O2, white solid Z. Where got? Oh, here, okay. So they ask me what is this? So you see this reaction, zinc chloride reacts with lead-2 nitrate. You get zinc nitrate and solid and white solid Z. So what is the white solid? What is the white solid? Zinc oxide. Oh, you get zinc oxide. Oh, I scared. Oh, okay. See, I write the equation. I write the equation. See whether we got. Oh, okay. I write the equation. Yeah. Okay. Zinc chloride, ZnCl2, reacts with lead-2 nitrate. What you get? What you get? Exchange, Zn and the nitrate. Pb and the Cl. PbCl2 plus Zn and O3 2. See? Zinc nitrate. So this one must be lead-2 chloride. Correct. Correct. Very good. Just like that. Easy, right? Easy. Now, I find other question for you to do. Got harder question, not. Blah, blah, blah. See, I remember I got at the back got a lot. Okay lah, never mind lah. Don't want to do already. Okay. Okay, don't want to do already because your level just kindergarten now, you still can't do the primary school question yet. So we have to go through some primary school knowledge so that you can do the whole question. We don't look at page number 2. Page number 2. Page number 2. So we go. Copper oxide is coal is brown. No. Copper oxide is always black. Cold or hot is black. The only brown is copper metal. Copper metal is Cu. If the Cu alone, it is brown. When the Cu paired with something, the ion is blue or black. So now, page number 2. I'm going to teach you how to do this preparation of salt. When you do this preparation of salt, there is something very important you have to know. The purpose why we do this part, why I'm giving you all this shortcut later, is to help you to find the reactants. Reactants means the ingredients. Ingredients to make salt. Let's say I want to eat CuCl2. I decided to make CuCl2 myself. But what are the ingredients? What are the reactants that I have to prepare? I have to mix. Okay. So preparation of salt tells you the ingredients of the reactant. And then another important part about preparation of salt is you've got to know how to do it. Let's say you make cake, you buy ingredients. How you make the cake? Do you need to put it into the oven? You do know. Okay, so this is preparation of salt. So we'll look at this part. So let me remove something. You see, this is how you do. Later you can refer back to this thing. So this is how you do. When you are given a salt, you have to ask yourself whether the salt is soluble or insoluble. Okay, let's say I give you 3 examples. Okay, so the first example here, KNO3 is soluble or insoluble? KNO3 soluble. Okay, see so it goes like that. Soluble. So if the salt is soluble, it goes to the left hand side and then hop 1, 2. We have 2 types of soluble salt. Can you see? Spa and non-spa. What is spa and non-spa? Spa is this sodium, potassium, ammonium. So spa is sodium, potassium, ammonium, which is the Na, K plus, NH4 plus. So the salt that comes with spa will use the first method. Later I will tell you what is the method. Okay, first method. So I put it here to show that it has a spa. Okay, and then MgCl2. This salt soluble or not? MgCl2. Yes, okay, so same, soluble, soluble. Roti canai is not pairing with persatuan agama or Hindu, so it is soluble. Soluble, so it goes to the left, and then hop. Got spa, not this one. Got SPA, not. No, here. No spa. Okay, can Lastly, for insoluble salt, okay, straight away go to the third method. So we have 3 methods to make salt. So it depends on the type of the salt. So how to do? See, first one, KNO3. When I want to make KNO3, what are the ingredients needed? What are the reactants needed? Do know, right? So we come to the bottom. We draw a cross and we write OHH. And then OHH. This is the first method. Soluble spa. OHH. So after I put the OHH, as I said, I want to make the KNO3, right? What I do, if I want to make this salt, I will just split it into 2 and put the ions like this. And then you can immediately, you see, this shortcut will give you the answer immediately. This shortcut tells you that, it tells you that you need K plus OH minus KOH. And then to react with H plus NO3 minus HNO3. So see, these are the reactants. Ingredients. That means if you have these 2 ingredients, you don't copy the equation. I show you only. It produces KNO3 H2O. Can you see? If you have the 2 ingredients in front, you can get this product. Okay, so all we need is the ingredients. So this shortcut, this cross, the cross helps you, the Ultraman cross helps you to find reactant. So this is the first Ultraman cross. You got OHH. You don't have to memorize first. I'm just showing you the example. Later I will let you apply it. Number 2, when we have a soluble non-spa. What was that? NCl2. Is it MgCl2? Okay, Mg. SO4. Mg SO4. So say we draw a cross. Then we put COOHH. COOHH. A bit different from the one just now, although they are two soluble salt, but a bit different. Same thing, I split the ion into two, Mg2 plus, SO4 2 minus. So what are the ingredients needed? Right hand side, positive, negative, we get H2SO4. On the left hand side, COOH. Hey, what are COOH? What is COOH? On the top here, can you see? These three. CO, and OH. So we are pairing this Mg with the CO, which is CO3 2 minus, O2 minus and OH minus. We get Mg CO3, MgO, MgOH2. So any one of the reactant here will react with acid to form MgSO4. Understand? This is how you find the ingredients. Okay? So you have to know what you want to make today. It's like you want to make egg fried rice. You need egg and the rice like that. Okay? So you want to make MgSO4, you need Mg and you need SO4. You cross it and you find the ingredients. Yeah, next, last is for the insoluble salt. Can anyone give me one example of insoluble salt? Example of insoluble salt, please. Oh, Malcolm, very good. Okay, let's say. Okay, so see, okay, many of you give me lead something. Okay, let me use lead something. So lead, let's say lead 2 chloride. Okay, PbI2, PbCl2. Roti canai and the persatuan. Roti canai and persatuan. Okay, so the cross. Well, the cross that we'll be using here is NSPA. NSPA. Oh, I say, okay. Oh, yeah. Okay. PbCl2, same. You split it into two. N is what? Nitrate. So Pb2 plus NO3 minus PbNO3 2. What is SPA? Sodium, potassium, ammonium. So let's say sodium chloride. That's all. These are the ingredients. So you have three methods to get ingredients, to find ingredients. Soluble SPA, non-SPA, insoluble. Let me give you a few examples so you can apply and see whether you can understand or not. Yeah. So I come back here. We need to wait. Okay, so let's say as you remember, we have three crosses. One, OHH, COOHH, and lastly the N-SPA. So we call this as the cross number 1, number 2, number 3. So now I will give you salt. You have to tell me which cross we use, first, second, or third. So let's say the salt, first salt is PbCO3. So how you know? You see the salt. Okay, you imagine the salt is here. You go left or you go right, soluble or insoluble. You decide yourself. So 1, 2, or 3. Which one? 1, 2, or 3. Nash, good one. Yes, Kassim, very good. 1, 2, or 3? Annabelle, very good. Yes, Kyrie, very good. Very good. So is PbCO3 soluble? Yes or no? Soluble or not? PbCO3 insoluble, right? I thought insoluble, then you go this way, 3. How come so many of you give me 1? Hey, not ask you to look at the OH and H. No, I'm asking you whether the salt is soluble or not. If it's soluble, you go left. Insoluble, you go right. Like that. You don't look at the cross. Yeah. Sonia's iPhone. Whose friend is Sonia? We almost end the class already, and she just want to join the class. Okay, never mind. We ignore this. I don't know who. Okay, see okay, so the answer is 3. Because insoluble. You all get it or not? Get out. Get out. I give another one. Why insoluble? I remove already. PbCO3, but sodium, potassium, ammonium. You don't tell me this is potassium, got sodium, potassium, ammonium nitrate or not? No, right? And then got COOH or not? Oh God, COOH is insoluble, right? All right. Right. Okay. Then next is AgCl. So which cross? 1, 2, or 3? First think, where you go, left or right? Yes, very good. So you see, it's in order to do very well in the salt, you can't forget what you learned in this chapter. You have to first accumulate everything up together. So AgCl, yes, is insoluble. So it goes to the right. We use the ends. Understand? Very good. Next, this one. KOH. Wow, that's good. Okay, very good. Very good. Yes, when you see the K, no need to think that must be soluble. And then which way you go? Of course, the one with spa. So number 1. Last. Okay, last already. Last already. After this, I want to sleep. CuSO4. Yes, the answer is 2. CuSO4. SO4 is Siu-Bao. But Siu-Bao has to be paired with cannot pair with persatuan bahasa Cina. This is not Cina, so soluble. Soluble means go to the left. Got SPA, not no. Then go here. Number 2. Get it? Okay, that's all. Just like that. So before we go do the exercise, okay, let me tell you how okay, you already know how to find the reactants by using the Ultraman cross. Now you have to know what is the reaction they use. For the first one, OHH. Why is it OHH? OHH is actually comes from alkali and acid. Acid is H plus, alkali is OH minus. So therefore, acid and alkali is neutralization. So please remember this reaction. Remember, neutralization reaction. How we do the neutralization reaction? We use titration. Titration means we add the acid drop by drop, and then in the end, the pink color turns colorless, that one. Okay, neutralization. Remember this reaction, very important. Later I ask you one. And then for insoluble salt, we use double decomposition reaction. So I just want you to remember two reactions: neutralization and double decomposition. Neutralization, double decomposition. Okay, yeah. So now we try the exercise at the back. We try to finish the whole page, which is where? Which is this one, page 29. Oh, I can't imagine I have to teach until 6. 10 o'clock. Okay. Okay. Substance P. Luckily, you all are not the last class. Okay. Substance P plus zinc chloride, you get zinc carbonate. So they ask you, what is substance P? If you want to make zinc carbonate, what is the ingredients that you have to mix with zinc chloride to get the zinc carbonate? Okay, see how we do it. How we do. So the 3 ultraman cross is here. OHH, COOHH, N star. So, classic, very good. The zinc carbonate that we want to make have to use 1, 2, or 3. Zinc carbonate soluble or not? Soluble or not? Soluble or not? No, that means if no, then we use which one? Insoluble, then which one we use? Yes, we use number 3. We use number 3. Okay, so you must know the solubility very well. So insoluble, we use N star. So see how I do. Zinc carbonate, all right. So I put my N star here. I put the cross. And then I split the ion. Zinc and carbonate. Why I so lag? Like your brain. I don't know. I'm not lagging. You are the only one that's lagging. Okay, you see. The N2 plus and the nitrate, you get zinc nitrate. Alright. SPA. Sodium paired with the carbonate, you get sodium carbonate. If you don't want to use sodium, you can use potassium. Do want potassium, you can use ammonium. Okay, can So now you see zinc chloride is already here. Already got zinc. That means they don't need my suggestion. They don't need my suggestion for the zinc nitrate. Okay, never mind. They only want the substance P. What is substance P? Natrium carbonate. Sorry, natrium is BF. Sodium carbonate or potassium carbonate. Understand? This is how I do. Find ingredients. I want to make zinc carbonate. So I find the ingredient. Already got zinc, then we don't want the zinc. We only take the half of sodium carbonate. Okay. Can then now they ask you, okay, see, okay, I write down the name first. Sodium carbonate. Name process Q. What is process Q? We are using Na2CO3 and zinc chloride to make this insoluble salt, zinc carbonate. Yes, very good. So the reaction is yes. We use the double decomposition reaction, the DDR. Okay, the double decomposition reaction. Okay, I write down. Double decomposition reaction. Okay. State the changes that occur during process Q. So when you do this, they ask you the changes. They ask you changes. Changes is the same as observation. So they're asking you, hey, when you mix Na2CO3 and ZnCl2, what can you observe? You see, this reaction produces zinc carbonate. And also what? This reaction will also produce, after you mix these two things together, you get zinc carbonate and also sodium chloride, correct? Zinc carbonate, sodium chloride, and NaCl. So what can you observe if there is zinc carbonate and sodium chloride? So you're going to tell me the color, the solubility. NaCl. What color is NaCl? Okay, good. This is soluble. And then the salt is white color. So that means when it dissolves, when you mix it with solution, it will be a colorless solution. Okay, so this is a colorless solution. It's like you can't see it. Zinc carbonate, color is white, but soluble or not? Insoluble. Insoluble white will be a white solid or white precipitate is formed. Okay, so always based on your equation, the product, you tell the color. Ionic equation. Okay, see, I teach you how to write ionic equation. For insoluble salt, it is very easy to write the ionic equation. They want ionic equation for process Q. Our insoluble solid is zinc carbonate. So we just write down zinc carbonate as our product. And then you ask yourself, what are the ions needed to make zinc carbonate, ZnCO3? Zn2 plus and CO3, 2 minus. Yes. So this is the ionic equation, that's all. Ionic equation, got ion, can you see? Okay, now you're going to try another one. They say, zinc carbonate react with solution T to form zinc sulfate, which is here. Let me remove everything. Very messy. Look at my cross. They want to make zinc sulfate by using zinc carbonate plus solution T. So what is the solution T? I wait for your answer. We are making zinc sulfate. We want to make zinc sulfate. Please tell me solution T. What is solution T? Which method you use? 1, 2, or 3? Yes, Kyrie, very good. Erin, very good. The rest of you, 1, 2, or 3, to make zinc sulfate. Zinc sulfate. Soluble or not? Okay, so you see, 燒包 is the 燒包 pairing with Persatuan Agama Hindu? No. If it is not, then soluble. Soluble, spa or non-spa? Zinc sulfate got spa or not? No. Then we use the second one lah. So we straight away put the zinc sulfate here. Okay, and you can also see that when they use zinc carbonate, only this cross got carbonate, must be this one lah, right? So you see zinc carbonate. H plus SO4 2 minus is H2SO4. So zinc carbonate is here already, so no need. We need a solution that means H2SO4. Yes, my next one is 4 to 6. I've been teaching since this morning, 10 o'clock. No break, straight 8 hours. Hi. I also do know who arranged this timetable one. Okay, H2SO4 is the solution T. Can you imagine a non-stop talking for almost 6 hours already. I didn't feel like talking anymore now. Solution T is sulfuric acid. Can use copper 2 sulfate. Cannot use copper 2 sulfate. Cannot use copper 2 sulfate. Why cannot use copper 2 sulfate? I know some students will say that, oh, we can use a zinc carbonate. We plus the what is that CuSO4, and then we can get zinc sulfate. But then carbonate and Cu is going to form CuCO3, which is insoluble. CuCO3 is insoluble. That means this process you get an insoluble salt, and this insoluble CuCO3 will actually mix together with the ZnCO3. The product form mixed with your ingredients, and they can't separate. And also, when this happens, the reaction cannot be completed, because what happened is, okay, you have a piece of zinc carbonate. You imagine this zinc carbonate. When they start to form CuCO3, when the acid reacts, they form the when they react the CuSO4, it will form the precipitate around it. Then the reaction will stop. So this is why we cannot use a different cross to do it. Cannot. Okay. So sulfuric acid. And the second ultralight cross. So now we try a few more. We try a few more questions. We look at page 32. Okay, see copper 2 salt plus water and gas Q. When we add dilute sulfuric acid, what are they doing? Okay, we look at this one first. Salt P, when it is being heated, it produces a gas Q. Gas Q turns lime water cloudy. So obviously the gas is CO2. So the salt that can produce CO2, the mum has to be, if your kid is CO2, then you must be CO3 2 minus, correct? So carbonate salt plus sulfuric acid. What is the salt? What is the copper 2 salt? Yes, correct. If this is carbonate, you imagine H2CO, H2SO4 react with something carbonate. So when you exchange the partner, what am I doing? Or something carbonate with acid, you will get no more battery. You will get something sulfate plus wait. Just a second, very fast one. Oh, I'm using eraser. Okay, X. With the SO4 at the back. Sorry, a bit very burning already. Okay, X. This one was eraser, that's why I cannot write. I think so. X and SO4. To something salt we do know lah. But what we know is H2 and CO3 is the H2O and CO2. You see, if you plus H2O and CO2 together, you get H2CO3. So that means the salt must be copper 2 sulfate. No? If this salt is copper 2 sulfate, that means this one is something carbonate. What is the something carbonate? Okay. It is CuCO3. Or there is another way to get the same answer. So when they want to react carbonate and acid, carbonate and acid is actually the second ultramarin cross. COOH. Yeah, got CO, got H. H, they use sulfuric acid. Means what? Means that the ion is SO4 2 minus. After these two things paired together, only can get H2SO4, right? And then this one is something carbonate. It's something carbonate. You do know what is the thing carbonate, but you can see that they form copper 2 salt. So that means this one must be a copper, copper. A copper 2 salt. You are making a copper 2 salt. And then they use sulfuric acid, then must be SO4. So you see this reaction, CuCO3 plus H2SO4 get you the CuSO4. So this is how you use the cross. CuCO3 plus H2SO4, you get CuSO4. H2O, CO2. Then, can you please tell me what is the precipitate R? What is the precipitate R? The precipitate R is? Yes, very good. The formula, yes. Calcium pair with the sulfate. Nitrate pair with the copper. Precipitate means insoluble. So which one is insoluble? Copper nitrate and calcium sulfate, which one is insoluble? Calcium sulfate. Okay, this is how you get the answer. This is salt. They always do like that. Ding, ding, dang, 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 for you to find. Okay, so you have to know precipitate is insoluble, color, the ultraviolet cross. Okay, so now we do one more question. I do one more question. Oh, okay, yeah. Remember at the back. Okay, got this. Okay, we look at this page 42. So the question says that this time really no battery already. Okay, can you please try this question? Find all the unknown. Like what is W, what is X, what is Y, what is Z? You try to answer this all the question in this page. You try. Done? Done? None. Okay. Okay, let's see. Solid W is a black powder. Black confirm copper 2 oxide. So CuO. And then state the color of copper 2 carbonate. Copper 2 carbonate is the one we go through earlier is green. Yeah, only one student say blue. Yeah, the student so weak say blue color. Okay. Suggest solution Y that is required to be added to solution of X to produce copper 2 carbonate. So they ask me, if I want to make copper 2 carbonate, okay, what is this solution X? What is the solution Y? So in order to get solution X, we got to write the equation first, CuO plus nitric acid. We get CuNO32 plus H2O. So can you see this is our CuNO32. CuNO32 plus solution Y to make copper 2 carbonate. Copper 2 carbonate soluble or insoluble? Insoluble. So we use this called N-spark. So copper 2 nitrate, can you see copper 2 nitrate plus sodium carbonate. Remember, you must use the correct cross. This is insoluble, then you got to use the insoluble method. Chemical equation for reaction 2. So my reaction 2 will be CuNO32 plus Na2CO3, getting me the CuCO3 NaNO3. To balance the equation, 2 NaNO3. So lastly, state the observation when excess ammonia is added into the solution of salt X. Oh no. This is about the ion test. Okay, never mind. This is all the ion test. I show you the answer. But remember, always use the cross to get all these solution. Ammonia plus copper 2 nitrate. Ammonia is a cation test. If you do not know, never mind, I show you the notes. Ammonia is here, page number 11. When you want to test, the Cu2 plus with ammonia, you will get blue precipitate dissolved in excess ammonia solution to get a dark blue solution. This one, I got time. Next time I explain now. Okay, next time I explain now. Today the maximum we can do is until the preparation. But you can always get the observation from the table. Blue precipitate dissolve and form dark blue solution. Okay. All the anion and cation test, you can get it from the front. But what I did today is I want to make sure that you can find all the unknown. Because by finding all the unknowns can get you many marks already. So you can try some of the example at the back. Okay, like this one, how to get the XYZ. And then you got this one, like how to find the WT, RQ, like that. All same method. Solubility, very important. Preparation, cross, very important. You want to put answer in the Google? Yes. Okay, yes. The answer will be put on the Google. On the website, I don't know. I still don't know where this what I don't know. I will see where they will say if they say website, then website I don't know. My iPad not charging, not charging. Okay, so thanks everyone for joining the class. Bye. I got another class. Bye. Thanks everyone. Bye. Anything you can ask me you do answer. You don't know. You don't get my phone number for the answer. No, please. No. Okay. Chinen, wait. Oh, Shen Yi. When Shen Yi, you WhatsApp me You WhatsApp me. I send you now. Okay. Now for those who want to screenshot the notes, you can screenshot. Wait, lagging. The answer will be posted on the website, I think. You get it from the website. You don't message me for the answer, please. Please, I got a lot of homework I haven't do. Next week I have to submit the nota already for next month one. You get from the website. Thanks. Okay. You got few questions now. Okay, for those who got question, okay, got question. Okay, how. Okay, can I give you. But no, okay, but I give you. Okay, I give you. I give you. I got reply or not? That one you cannot. I'm not sure I got reply or not. You can ask my student. I know always no reply one. Okay, I try my best. Okay. Yeah. Try my best. Thanks. Bye bye. Wait. Yeah. Wait. Trinan, you which page? This one. Done? Is it done? This one. Screenshot. Okay. Okay. Then this one. Yeah. Why don't you fill up the form and let them send it to your house? Okay. Hey, you got a BM one. Okay. Sorry. You got a BM one. Okay. Like. Can see me? Okay. Then okay, the gas test. Okay, screenshot. Then this one here. Lag. Wait, why lagging again? Okay, next. Okay, ion test. The last one. Wait, not last one. Okay. This one is the last. This one we screenshot 2 times. This one. Okay, this one time. Okay, and the exercise like that. Okay. Bye bye. I got another class now. Bye bye. See you all next week. Not next week. I don't know when.